Hi everyone, welcome to Vedantu English. I'm Diksha Kaushal, your chemistry master teacher. So everybody do let me know in the chat box if I'm clearly visible and audible to all of you so that we can start with today's session. Yes everybody, so today our topic is hydrocarbons and it's a very important chapter, and you will see a lot of direct questions are asked from this particular chapter, right? No doubt the chapter is little lengthy, but we will do that right in just 3 hours. So everybody, if you're ready, then do let me know in the chat box, right? Okay, so everyone ready? And what are you doing, guys? Have you hit the like button or not? No, right? Super confused, right? So hit the like button, motivate me, right? So yes, everyone. Let's start. Hi Adarsh, Santosh, Hema, Pritija. I'm perfectly fine. William, Zynex, Nandini. Yes. Okay. So, very good evening. Very good evening. Let me see how many likes you have given to the session. Only 7 likes till now. What is this, guys? What is this, guys? 29 of you are watching. Then hit the like button. No, right? I'll just, how many of you have done that? Let me refresh it again. I am also full stubborn. Now it's 11, only 11. So I'll see that in 5 minutes how many likes you have given, okay? Yes. Definitely, Hema, you can watch it for NEET as well, right? Okay, so let's start the session, guys, without wasting any time. So here, wait a minute. Yes. Here, first thing is hydrocarbons. If you talk about hydrocarbons, that contains hydrogen and carbon. So in this case, we have firstly aliphatic, that is, in case of aliphatic, the one that are not in the cyclic chain, that is acyclic, they can be saturated, they can be unsaturated. Saturated means single bond, unsaturated can have double bond or triple bond, right? And in saturated you have alkanes, in unsaturated you have alkenes and alkynes. Alkene is double bond and alkyne is a triple bond, right? So then we talk about cyclic thing. In cyclic, there can be homocyclic or heterocyclic, right? In case of homocyclic, there can be aromatic, non-aromatic, anti-aromatic, that we have already done in GOC, right? Okay, so in cyclic also we'll study about that, but firstly our main thing is going to be, we'll study about alkanes, then alkenes, then alkynes. Direct questions are asked from its preparation and properties, and you will see a lot of questions being repeated here, right? Going forward, I want to tell you before the difference between N-neo and iso. N means normal chain, iso means whenever a carbon, there is a carbon which is connected to 2 methyl groups. If you see, this carbon is connected to 2 methyl groups, then this will be iso. So you will remit iso, and how many carbons you have? 1, 2, 3, 4, 5. So it will be isopentane. And what about this one? Whenever a carbon is connected to 3 methyl group, 1, 2 and 3. I am not talking about 4th methyl group. See, iso means you will have 2 methyl groups, right? 2 methyl groups will be there, and that will be called as iso. Okay, if here it is only hydrogen, that is called as isopropyl. If there is only further CH3 attached, that will be isobutyl. If it is CH2, CH3, it will be isopentane, right? So this group should be present in case of iso, right? In case of neo, we are saying that a carbon with 3 methyl groups mandatory, and 1 more carbon here. So if I write this, if you say, ma'am, this is iso 1, 2, 3, 4, ma'am, this is neobutane. Neobutane does not exist only. Neobutane does not exist. Neopentane exists, right? So here what you will have, this carbon is connected to 3 methyl groups, and then 1 more carbon So first neo compound is neopentane, right? Okay. So what about this one? If you see, this is carbon connected to two methyl groups, and how many total carbon? It is 1, 2, 3, 4, 5, 6, 7. So it is isoheptane. And what about this one? Here you have carbon which is connected to 1, 2, 3 methyl groups, and further one more carbon. So this part will be called as neo. So it is how many carbons? 1, 2, 3, 4, 5, 6, 7. So it will be neoheptane. Okay, everybody, that is the difference in neo, iso. Tell me. Okay, tell me, everyone. Yeah, we have I've already done coordination chemistry, right? Iso will be 2 methyl groups, neo will be 3 methyl groups attached to second carbon, right? This I have already told you. Now let's talk about the preparation steps. Okay, guys, let's talk about the preparation steps. Yes, what about the preparation? What about the preparation, everyone? Let's see. In preparation, first thing is from alkenes. Alkenes means double bond. So first thing is when we do hydrogenation. In case of hydrogenation, you just add H2 in presence of some catalyst like nickel, platinum, all these are catalysts. So what will happen here? This one pi bond will break, and with that you will have the attachment of hydrogen and hydrogen here. That is called as a hydrogenation reaction, right? And in this kind of reaction, what exactly happens? Whenever you have a catalyst, this reaction takes place on the surface of catalyst. So this is on the surface of catalyst. It is an exothermic reaction. There is no intermediate, there is only transition state. For example, this is CH double bond CH2, right? Here you have H and S. So what will happen? This particular bond will start breaking, right? And this new bond will start getting formed, right? This new bond will start getting formed. This bond will also break here, right? So what you will see the formation of this kind of situation which is on the surface. That's why there is no intermediate, there is only transition state, right? Okay, 4-member transition state, as you can see, when this bond is breaking, and there is formation of new bond. This is a 4-member transition state that is formed here. Now second is same, it is like hydrogenation only, but here we have given a specific name because we are using a specific catalyst here. So in this case we are using nickel catalyst, right? So when you have alkene with double bond and when you have alkyne with triple bond, what happens when you have hydrogen, you have a catalyst, then what will happen? The pi bond will break and you will add H2 here, and only 1 mole of H2 is required to break 1 pi bond. To break 2 pi bonds, we require 2 moles of H2 here. Catalyst can be nickel at 200 to 300 degrees Celsius, and Rene nickel will be used at, if you don't want to increase the temperature, then you will use Rene nickel, right? If you can increase the temperature, then you will use simply nickel. But 200 to 300, for 200 will be for a conversion of alkene to alkane, 300 will be for conversion of alkyne to alkane. Okay, right, everyone? Tell me. Yes, definitely that will be done. Don't worry about that. Soon I am going to take up your lecture on aldehyde ketones, carboxylic acid, amines, biomolecules. Don't worry about that, right? Okay, so hydrogen is added to first and fourth position. Now this is 1,4 addition. How does this work, right? So let me just tell you this with the help of, let me just do it myself so that you are able to understand this more clearly, that what we are doing here. let's say you have this thing, okay, you have this thing, okay, this is the compound that you have, okay, this is the bond that you have. Now see what is happening here. This is H and this is H, okay. This is 1,4 addition. How does 1,4 addition? If you have alternate conjugate bonds of alkene, then how 1,4 addition works? This particular bond will shift here, this bond will shift here, and this bond will shift here, right? If you see, then it will lead to the formation of, this is CH2, this is CH, this is again single bond CH, this is again CH2. Now this bond has shifted here, so I'll have a double bond. This bond has shifted here, you have bond here. This bond has shifted here, you will have a bond here, and that is connected to 1,1 hydrogen here. For example, you have added, let's say you have added deuterium here, right? Let's say you have added not hydrogen but deuterium here. Now what you will see, let's say you have added deuterium here, you will see the addition of deuterium on 1 and 4th position. Now if you see this particular thing, what you will suppose, that if you have this kind of bond, you will think that this pi bond will break, deuterium will attach here and here, or this pi bond will break, deuterium will attach here and here. But in reality, you don't have this thing. In reality, guys, you don't have this thing, right? In reality, what you have is, in reality, you have the addition at 1,4 position, okay? That is why 1,4 addition is so important for you to know, that how 1,4 addition works, right? Okay, yes. Now, let's see this thing, no, this I was not supposed to do here, right? This we are supposed to do somewhere else, okay? Now, from alkyl halides, if you see from alkyl halides, so many things are possible. First is, what you have to do, you have to replace this halogen with hydrogen. So whenever you are replacing halogen with hydrogen, right, we are using here nascent hydrogen. Catalyst can be zinc with acid, zinc with acetic acid, zinc copper coupled with alcohol, red phosphorus and HI, AlHG, ethanol. All these reagents can be used to convert this, because these all reagents are producing nascent hydrogen. They all are producing nascent hydrogen, okay? They all will be producing nascent hydrogen. That is why this is used to convert halogen to hydrogen, okay? The next way of converting alkyl halide to alkane is very important, Woods reaction, okay? Very important, Woods reaction. In Woods reaction, what you have two alkyl halides, you have sodium, right? And what will happen, this will be eliminated to give you RR, that is alkane. And this alkane will always be a symmetrical or even number of carbon alkene, always. Now what you will see here, why only dry ether is used? Now sodium is quite, sodium is electron deficient, so ether is used. It is lone pair which facilitate more solubility of sodium. So sodium is Na positive, which is electron deficient, right? Or even if you see this Na positive here, it is electron deficient. So we know ether, which has lone pair of electrons, it is going to donate these lone pairs here, right? Second thing is, ma'am, why, ma'am, it is dry ether? Because sodium is quite reactive in moisture, that is why dry ether is used. And moreover, in ether, when it is getting soluble here, when ether is getting soluble with sodium, then it releases a lot of energy that helps in this particular reaction, okay? And in Woods reaction, as we know that you need to break this bond. You need to break the bond of carbon and halogen, right? Down the group, we know that the size of halogen is increasing. That is why the length is increasing, so it will be easy to break that, right? That is the reason we are easily breaking this particular bond, and that is why Ri is highly reactive as compared to RCl. Now ma'am, why RF? RF is not used, you will not see these in terms of reaction, it is very explosive in nature, okay? So only unsymmetrical and even number of alkanes are formed here. Methane is not formed because it is always RR. So at least even if you have one carbon, then double of it, that means 2 carbon will be formed. So methane is never possible here, right? Okay. Then guys, next is intra is preferred over inter. Acha, this to, yes. One important fact about this particular reaction is that this reaction proceeds via free radical mechanism. Okay, so now I'm going to tell you a very important question, right, that they ask you in this particular reaction, right? So let's say a question like this is given to you. They have given this is butane, this is 1, this is Br, and this is also Br. Now as I am telling you, this proceeds via free radical mechanism, so this can take place. So free radical, this bond will break here, this bond will break here, and you will have the formation of free radical on both the places, right? Okay, you have the formation of free radical is there, right? You have the formation of free radical. Now 2 possibilities are there, right? One is intermolecular, second is intramolecular, right? What is the possibility of intermolecular? In intermolecular, 2 molecules, right? 2 molecules will be joined together, and hence you will have something like this, right? This is first molecule, this is the second molecule, right? It will join together and will give you this, right? 2 molecules are joining together. But if you talk about intramolecular, in case of intramolecular, you have this thing, right? And in this case, right, this is already a double bond. Intramolecular means these 2 dots you will connect here, right, and it will form this thing. Now the question that arises is, ma'am, which one is more stable here? So remember, always intra is preferred. Intra is preferred over intermolecular. That means intra means this should be preferred. Intra should be preferred. But there is also exception in that, right? Intra is preferred, but if this becomes anti-aromatic, that is 1, 2, 3, 4, it has 4 pi electron, it is anti-aromatic in nature. It is anti-aromatic in nature. So whenever this is anti-aromatic, intra is not preferred, but inter is preferred. Okay, this will be choose, this will be not selected here. Tell me, yes everyone, is that clear? Is there any problem in this particular part that we are doing? Let me know in the chat box if there is any problem here, right? Okay, yes. So let's talk about next thing, that is, just like Wood's reaction, you have fatigue reaction in which instead of alkyl you have aryl halides. So this and this will go, and 2 phenyl rings will be connected and it will form diphenyl here, just like you had the formation of RR. These are 2 phenyl groups, so that is diphenyl here, right? So then there is Frank-Land reaction. So in case of Frank-Land, so who is very frank? Zinc is quite frank in nature, right? So instead of sodium, you are using zinc here, but in the same manner, you have the formation of symmetrical. So that is why this is also not of use here. Then you have Corey house synthesis, and this one is important. Why? Till now, not so many questions they have asked on this, but this is important because here you can form unsymmetrical alkanes with high yield, right? So if you want to form unsymmetrical alkanes from alkyl halides, what you can do is you can choose the path of Corey house synthesis. What is the reagent here? That is Gilman's reagent, that is R2CuLi. This is the Gilman's reagent that you have. There is a man whose name is Gil, right? And he is always in Core's house, right? So Gilman's reagent is used and this R will be substituted here, right? And hence this is the answer that you are going to get. This is R2. So this R will be substituted here, right? That is the answer that you will have in the end. That is unsymmetrical alkanes are formed here, right? Okay. Then very important reactions are from carboxylic acid. First is decarboxylation reaction. Let's talk about decarboxylation reaction. Yes, everyone? Decarboxylation reaction. First is soda-lime decarboxylation. In this case, if you see soda-lime, that means soda means caustic soda and this is quicklime, they are used. And here you will always have the formation of RH as the product, right? And what is the intermediate that you use here? That is carbanion intermediate is formed here. Carbanion intermediate is formed here. Okay, mechanism and all, even if you don't remember, that's okay. Just remember that the intermediate is carbanion. Just remember the intermediate, that in case of soda-lime decarboxylation, the intermediate is carbanion, right? Next is Kolb's electrolysis. It is quite similar, but in this case you have the formation of, this is also RCOONA, and this is electricity is produced here, and here you have the formation of RR, right? So that you must remember that in case of soda-lime decarboxylation you have the formation of RH. In case of Kolb's electrolysis you have the formation of RR, right? Okay. So next, all this mechanism you can go through or you can skip as well, but what is important for you, that at anode what happens? Now we know that this will be dissociated into CH3COO negative and Na positive. This will lose 2 electrons and this will form a free radical, that is CH3COO free radical, and after that what will happen? This bond will also break. So this bond will also break, and what is going to happen? This bond will break. This will give you free radical here and a free radical here, and it is going to eliminate CO2 from here, giving you alkane at anode and CO2 at anode, right? What is important? At anode you have the formation of alkane and CO2. At cathode you have the liberation of H2, and it is a basic medium. Okay, this all you have to remember. I'm just gonna write it here as well. At anode you have the formation of RR and CO2 is liberated at anode, and at cathode you have the liberation of H2, and overall this is a basic medium. Okay. Then we have reduction in, reduction is done using red phosphorus HI. So if you talk about the reduction case, that will be done, all will be reduced to alkane, with the same number of carbons, like this will be RH, this will be RCH3, this will be RCH2Cr, this will be RCH3. Okay, so same number of carbons will be there, it will be reduced to that, right, with red phosphorus and this. Now let's talk about 3 reducing agents, that is, hello, Shravan, Santosh, yes, it is me, Kiran, ma'am is not responding to the chat. Array, how do I respond to the chat? Whenever I see someone is asking some question, then I definitely respond. So is a strong reducing agent? Yes, for some cases it is definitely a good strong reducing agent, right? Okay, Yes. Right? Yes, done. So, now reducing agents are LiAlH4, NaBH4, PH3SNH, all are reducing agents. So, here, simple direct thing I am giving you here, that in this case, if you talk about primary, in case of primary, this will LiLH4 and PH3SNH, they will convert it into alkane, but NaBH4 will have no reaction here, right? Others will do the same. See, in every case, your compound is getting reduced to alkane, but if you talk about NaBH4, it will not show any reaction. But if you talk about LiLH4, with 3 degree, it converts it into alkene. Okay? It converts it. This is, we are talking about alkene to alkane. When you are using these reducing agents, then NaBH4 will have no reaction with primary and LiLH4 will form alkene with tertiary. Okay? Yes. Okay. Yes. Next is two important reductions, Clemmensen and Wolff-Kishner reduction. In Clemmensen reduction, what you will have a compound that is, in a better way, we can also write it like this. Okay? Instead of writing R and R, I'll just write it here like carbon. So, you will have carbon on both sides, right? Now, what will happen in case of Clemmensen reduction, right? This double bond O is converted to CH2. That is what we are doing. C double bond O is converted to CH. This is what we are doing here, right? Okay, yes everybody, tell me if that is clear to all of you or not. And here in the case of Wolff-Kishner also will do the same thing, but in case of Clemmensen we are using zinc amalgam and acidic conditions are here. That is why we are using acid here. Acidic conditions are there. But in case of Wolff-Kishner reduction, you are using dihydrazine and you are using KOH, that is you are using basic conditions here. Reaction is same, okay? The reaction is same. Wait a minute, this is misprint here, right? This is misprint here. This will be converted to C, this is H, this is H, this is O. Okay? Right everyone? That is your Wolff-Kishner reduction. Right? Next is from Grignard reagent. Now from Grignard reagent, what you will do? So firstly, we need to know what is a Grignard reagent. Grignard reagent is an organometallic compound. Right? Okay? Means aldehyde and ketones. Yes, Harshini. Yes, that is aldehyde and ketone. And this is hydrazine. And this can be aldehyde and ketone, and that double bond O is converted to CH2 here. Okay? So, if you see from Grignard reagent, what is Grignard reagent? Grignard reagent is an organometallic compound, that is RMgX, where this is negative and this is positive. A good thing about Grignard reagent is that it shows one category. See, other category will do in aldehyde and ketones. First category of reaction is that whenever it sees a proton source, it will be converted to, whenever you add a proton source here, it will directly be converted to RH here. Any proton source you give it, any proton source, right, which is going to give you proton. So, any proton source you give, this is converted to alkene, right? Any proton source. Now, this proton source can be water, alcohol, alkyne, which is giving you proton easily. That is your proton source, right? Okay. Then let's talk about physical properties of alkane, right? Okay. Migration of compounds, yes, definitely it is important, right? So, rearrangement you're talking now, definitely that is important, right? Okay, Naga, that is important. So physical properties of alkane. So these are all the physical properties, you can do yourself as well, right? There is no need to point that out. I'll see what is there to explain. So alkane have less density than water, right? Because they don't show hydrogen bonding, they have less density than water, right? Water shows hydrogen bonding, that's why it is heavy. It forms a good hydrogen bonding network, right? Melting and boiling point, if you see, melting point depends upon the packing efficiency, and packing efficiency always is more for even than as compared to odd. So always melting point of even number of carbons will be more as compared to odd number of carbons, right? And if you talk about boiling point, that is directly proportional to molecular mass and inversely to branching. If so much branching is there, like for example, if you talk about 3 degree, if you talk about neo has a lot of branching, that is why its boiling point is less. Then you have iso, then you have N, okay? That is one of the examples that you can take here, right? Okay, and more is the number of carbons, more will be the boiling point if the branching is same, right everybody? Okay, yes. Packing efficiency is a term that we use in solid states. How much packed they are in the lattice structure, are they close to each other or are they away from each other? This is what we call packing efficiency. But you just remember this thing, okay? Only that much. Now let's talk about color and odor. This is about color and odor, what are colorless, all this is data is given here. Then let's talk about the solubility. For solubility, alkanes are non-polar. Can we see there is no as such polarity here? Carbon and hydrogen, there is no that much high electronegativity difference here. So they are non-polar in nature. We can definitely say that they are non-polar. Therefore, they are soluble in non-polar. Therefore, they are soluble in non-polar solvents, right? And insoluble in polar solvents. Non-polar solvents, they will be soluble in that, right? Because like dissolves like, because they are non-polar, they will be soluble in non-polar solvents, right? Then we have solubility is directly proportional to molecular mass. More is the molecular mass, more will be the solubility of that, right? Because the van der Waals interactions will be more here, right? Definitely you have Chitra, electrophilic, nucleophilic addition reactions, you definitely have, right? Then let's talk about chemical properties of alkanes. Let's talk about chemical properties, everybody. Do let me know if you are ready for this or not. Yes. Yes, students, everybody in the chat box. Chemical properties. What are these chemical properties of alkanes? Let's discuss that. Ready, everyone? Chemical properties of alkenes. This is a very good revision session for you. Very good revision will be here, right? So I have not deleted any part from hydrocarbons in this session. Why I am doing fast? Because this is a very lengthy chapter, right? So I am here on the perspective of revision so that you can revise things, right? And everything can get into your head and you can know what is important and what is not, okay? So if you talk about complete oxidation or combustion, now in this case, endothermic reaction. So whenever you have, let's say, alkene, firstly they show combustion reactions. That means with oxygen they will form carbon dioxide and water and they will release heat here, right? Wait a minute. And this is not endo. This would be exo. Combustion reactions are exothermic reactions. Okay? These are exothermic reactions. Okay? Due to evolution of large amount of heat during combustion, alkanes are used as fuels. Right? So now we know that alkanes are highly used as fuels because a lot of amount of heat is produced in their combustion. That is the first thing. Second, now we have seen, this is again endothermic. Wait a minute, let me just delete it here. This is exothermic, not endothermic, okay? These are exothermic, right? Acha, now let's see this. Complete oxidation should be there, as you can see. Now this I have already told you, this is CnH2n plus 2. Here it will use 3n plus 1 by 2 oxygen and n amount of carbon dioxide, n plus 1 amount of water will be formed. If you use CnH2n, then Cn simple is, yeah, remember that if you have 3n by 2, this is n and this is also n. If you add 1 here, if you add 1 here, like 3n plus 1, then here also 1 will, here 2 will, here also 1 will be added. Okay, so if you add 1 here, here also 1 will be added. Okay, if you don't add 1 here, here also 1 will not be added. If you subtract 1, here also 1 will be subtracted, right? So this is just a way of remembering. This is a reaction that we will again and again see for alkane as well, alkene as well, alkyne as well. So this is the oxidation of alkane. This represents alkane. Now in alkane you have CnH2n plus 2. That's why we have added plus 1 there. Here it is nothing plus 0, so it will be nothing we have added there. It is minus 2, so it will be minus 1 and minus 1. This is just a way of remembering. And this complete oxidation will be used in other parts of chemistry as well, like in some basic concepts of chemistry, mole concept, they simply say in complete combustion of heptane, how many moles are formed, then you have to apply stoichiometry there. For that you should know these 3 generalized reactions where you will just put the number of carbon and you will get your answer, right? Okay. Then incomplete, whenever incomplete oxidation is there, simply you will get carbon, right? Carbon black as the answer. When full combustion is there, then you will get carbon dioxide, right? Then guys, we have controlled oxidation. These are very important reactions directly from your NCERT. These 3 reactions are quite important. Usually students skip this, but this is important. CH4 with O2 gives rise to methanol. CH4 with O2 in presence of molybdenum oxide gives you aldehyde. Ethane with O2 in presence of manganese acetate will give you ethanoic acid. So this is alcohol, aldehyde and acid is formed, right? This is copper, molybdenum and manganese. Copper, molybdenum and manganese, that's how you can remember this thing, right? Okay. Then next is, if you have tertiary alkane, like you have 2-methyl propane with oxidation in presence of KMNO4, it will just convert this hydrogen to OH directly. Okay, this is also a very famous and important reaction, right? Okay, everybody. Next is hydrogenation reaction that we will do further in detail, right? In haloalkane, haloarenes, we have detail of this particular reaction, right? Now in halogenation reaction, you have alkane, and when you add halogen into this in presence of some sunlight, then 1 hydrogen will be replaced by Cl, then again 1 hydrogen by Cl, again 1 hydrogen by Cl, again 1 hydrogen by Cl. So what we are doing here, this is actually following a free radical mechanism. And always remember, if you have helper, heat, electricity, light, peroxide or any radical, it will always give you free radical mechanism. Okay. Now next is nitration. In case of nitration, add HNO3, H2SO4, hydrogen is converted to NO2. In case of sulfonation, add oleum or concentrated H2SO4. This hydrogen is converted to SO3H, right? Then chlorosulfonation, this one is very important reaction. Can you name this reaction? This is Reed's reaction. This is very important reaction. This is very important naming reaction, that is Reed's reaction. In case of Reed's reaction, this RH you add sulfuryl chloride, that is SOCl2, then this H will be converted to Cl here, and hence you will have the formation of alkyl halide here. Then very important reaction, aromatization reaction. This is also very important. In this case, what you have the carbons, right? Simple open chain you have 1, 2, 3, 4, 5, 6 carbon open chain you have. You add chromium oxide, vanadium oxide, molybdenum oxide at very high temperature and pressure is 10 to 20 atmospheric. This will directly be converted to that number carbon, that carbon number of aromatic ring, like you have benzene here. Okay, this particular reaction is also, you will see in PYQs, it has been repeated, not directly they have asked you, but you know there are reactions like A to B, B to C, then C to D. In those kind of reactions, these things are asked, right? Then if you talk about aromatization of N-octane, right? There is N-octane here, 8-membered carbon you have, right? In this case, 6-membered carbon of this will be formed, then 2 methyl groups will be attached like this, or only 1 ethyl group will be attached. So aromatic ring will be formed, because see, if you say, ma'am, why not this? Now the question can be, ma'am, why not this, ma'am, if it has 8 carbons, isn't it? Beta, is this aromatic? Is this aromatic? We have studied it in aromaticity. Tell me, is this aromatic, non-aromatic or anti-aromatic? Let me see if you remember this or not. Let me see. Tell me. No issues ignited. Tell me. Major will be orthoxylene. Yes. Not at all. Not at all. It's not at all same, Henry. Yes. It is anti, ma'am, right? It is anti that. It is not anti-aromatic here. It is non-aromatic because of its tub-like structure. Huh? Forgot kya? 8-annuline is anti-aromatic. Sorry, non-aromatic. So definitely 8-membered we cannot form. It is non-aromatic, guys. It's not anti-aromatic. Okay. 8, 10 and 12 annulenes are non-aromatic in nature, right? So that is the reason 6-membered is formed and with the methyl groups attached. Okay. Yes. Then reaction with steam. If you react it with steam, then what is going to happen? Carbon monoxide you are going to have, right? Then we have pyrolysis. It's not an important reaction. It's just you should know what is pyrolysis. Decomposition of a compound by heat. Now this particular 6 number of carbons is dissociated to 6 number of alkene, 6 number of alkyne, 6 number carbon alkyne, 4 number, 5 number, 3 number, 2 number, 1 number, right? So that is when you have a stick and you break it into small pieces. That is called pyrolysis. This is what we are doing here. So there is no specific product that is formed here. That is why this reaction is never asked. Okay, right? That's why I am not mentioning anything here, right? Okay. Yes, everybody, tell me. Is that clear? Is that clear? Wait a minute. Okay. Yes. Wait a minute. Wait a minute. Okay. Isomerism, we are not going to talk about isomerism, right? Because isomerism I've already talked about. So I'll just show you overview of this. In case, let's start with alkenes, right? Now let's start with alkenes, right everyone? Let's start with alkenes. Yes, students. Ready for alkenes? Tell me. No, I'll cover a full chapter, right? That's why I'm super fast, right? Okay, I'll be giving you questions for your homework only. Questions I'm not going to do here. I'll be giving you PDF. You can do the questions yourself because that much time we will not get here, right? Okay, yes. Uh-oh. Am I better in class or am I better in thumbnail? That you tell me. Achha, see, if you talk about isomerism, right? In case of isomerism, structure isomerism and geometrical isomerism are there. And alkene shows chain isomerism and position isomerism both. Chain isomerism means you can have different parent chain. This is 4-membered chain. This is 1, 2, 3. 3-membered chain is the major chain. So if chain is different, then it is a chain isomer. Position isomer means the double bond position is different. This is different and this is different. This is on the first position, this is on the second position, right? Then it also shows you functional isomerism sometimes, right? Alkyne and alkene is also interconvertible. Then let's see geometrical isomerism. It shows you cis and trans and Ez. Beta, we have already covered it in our isomerism lecture, right? Okay, then let's talk about the stability of alkene. Which alkene is more stable? Tell me. Now this is based on alpha hydrogens. More the alpha hydrogens, more will be the hyperconjugating structures. Okay, I'll just show you here. See, if you see this particular alkene here, you will see this is alpha carbon. This has total 6 alpha hydrogen. Here, this is alpha, this is alpha, this is alpha. So it total has 9 alpha hydrogen. So definitely this is going to be more stable. And this is called as Set-Zepf rule, right? And this is called as Set-Zepf rule. Set-Zepf rule. What is Set-Zepf rule? Set-Zepf rule states that if you talk about an alkene, more the alpha hydrogen, more stability it will have. Simply what you have to calculate is more alkyl substituted alkene. That's it. This has 2 alkyl groups, this has 3 alkyl groups, and that is the reason this is more stable, right? So, and more is the stability, more will be the heat of hydrogenation. So they can also ask you in terms of heat of hydrogenation or stability. So in this case, tell me, this is alkene, this is alpha, this is alkene, there is no alpha. So there is 0 alpha hydrogen, here it is 3 alpha hydrogen. So this is more stable and this is going to have more heat of hydrogenation, right? Okay. Yes. So now let's do reactions from alcohols. Let's do this, everybody. Let's do reactions from alcohols. Okay. Let's do reactions of alcohols. You can like from alcohols, how it is formed. Yes. Beta, we will talk about that. Okay? Chalo. Now let's talk about from alcohols, right? So we know that in alcohols what we do, we use concentrated H2SO4, which is a very strong, very good dehydrating agent. So what it is going to do, it is going to cause dehydration. That means it is going to eliminate water from here, right? So this is your structure, and from the alpha position where OH is attached, it will eliminate OH, and from the beta position it will eliminate H, and this bond will be shifted here, and hence you will have the formation of alkene. And always remember, more, according to Sedgwick rule, you will have more stable alkene. The one which has more alkyl, for example, here so you have only one beta. For example, here also you have beta, this is beta, then this is gamma. Then, ma'am, if you have 2 beta, you have 3 beta carbons. Then from which beta position hydrogen will be released? From that beta position where the product is according to Sedgwick rule. Okay? Now, from alkyl halides, what you have to do? From alkyl halides, see, whenever there is alcohol, you have to do dehydration. For dehydration, we use P2O5, H2SO4, Al2O3, all of these are good dehydrating agents, right? But what about good dehydrohalogenation, which will eliminate halogen and hydrogen and form alkene? That is going to be alcoholic KOH, not aqueous, alcoholic KOH, okay? So alcoholic KOH is that reagent which is going to cause dehalohydrogenation reaction, because here we are talking about breaking the CX bond, that is why Ri, then RBr, then RCl is the reactivity, right? And here 3 degree, then 2 degree, then 1 degree is going to be the stability, because here there will be formation of carbocation, and that is the reason this is the reactivity order. Okay? Okay? Remember that this is beta elimination. From beta position, hydrogen is being eliminated. Then third is vicinal. Vicinal means when on the adjacent carbons you have halogens. That means you have to eliminate halogen from this side, then it will shift here, right? Now that means you have to eliminate halogens, dehalogenation you have to do here. In that case, we use zinc dust, right? That's it. At very high temperature like 300 degrees Celsius, and directly it will be converted to alkene. Okay? Right? Yes, everybody? Tell me. Right, everybody? Someone also, alcohol sometimes dilute, sometimes frustrating. You have to revise it again and again, multiple times. Now, if I talk about myself right now, I don't have to remember. It's on my tip. Like it's on tips, right? So, more you revise, more easy it will be. Now, I know that whenever you talk about dehydration, what is there? Dehydrohalogenation, what is there? Dehalogenation, what is there? Right? That's how you can remember these. From geminal, geminal means when on the same carbon you have 2 halogens. Now if you have to eliminate this thing, now what you will do? See, one thing, wait a minute, yes. In case of this also you will use zinc dust here. Okay, in this case also you will use zinc dust here, and that will be eliminated, right? Okay. Yes, everybody? Tell me. Now, important reaction, that is formation of alkene from alkynes. So, when you have alkyne, how do you form alkene? So, there are 2 possibilities. First is from Lindlar's catalyst, we have the formation of cis alkene. From if you want to form trans alkene, you will use Birch reduction. So, if you have alkyne, you are using Lindlar's catalyst, that is, you are using H2, PD, BaSO4. This is Lindlar's catalyst. You are using hydrogenation in platinum, but that is in the presence of some poison like sulfur poison is there, to stop the hydrogenation at alkene part, because we don't want to further go till alkene, we want to form alkene. In this case, you will have the formation of cis alkene, not trans alkene. Cis alkene means on the same side you will have alkyl groups, and whenever you use sodium or lithium in presence of liquid ammonia, that is called as Birch reduction. and in this case you have the formation of trans alkene, right? Okay. Then we have Kolb's electrolysis. Now tell me, is that clear everybody? This is clear now. What is Lindlar's? What is cis? What is trans? When cis is formed? When trans is formed? Right? Okay. Now next is going to be, next we are going to have Kolb's electrolysis. So everybody tell me. Kolb's electrolysis, we have just discussed about Kolb's electrolysis. What we discussed in Kolb's electrolysis? Tell me. What we discussed in, yes ma'am, terminal alkyne doesn't undergo Birch reduction. Yes, definitely it is because of the mechanism, right? For that you have to go and watch my detailed lecture. Guys, in 3 hours I can't cover mechanisms plus everything, right? Okay. So if you want to go through, and plus one more thing, I am telling you the mechanisms highlights, okay, the important points related mechanism, like Wood's mechanism is free radical mechanism. Why I am telling you that? Because those things are used in the exam. Birch reduction mechanism is never asked, right? But if you still want to do it in my detailed video, okay, right? So tell me, ठीक है? Okay. Now let's talk about Kolb's method. Kolb's method, IITN guys. Acha, you are 2027 aspirant. Don't worry, we have so many things coming for you, right? But this session is specially for those students who have their exam in just 60 days, right? So that's why I'm revising things in a fast manner, right? I'm only doing important things. I'm not doing unnecessarily things here, right? So if you are here to increase your knowledge, then I think you need to watch the detailed 7-8 hours of session, and I have taken in parts, I have taken hydrocarbons. Go and watch that. But here only those students should stay who are there for revision. You just want to revise and brush up things, right? Okay. So Kolb's method, if you see guys, what we have done, that in Kolb's method, what you had, elimination of this CO, and you had the free radical formation. So it had the formation of CO2 because it's a free radical mechanism. Here you have this free radical and this free radical, then it will join and give you this alkene. Okay, that's how you have the formation of this thing. Can you explain Kolb's electrolysis? Yes, Kolb's electrolysis same as Wood's mechanism. Woods, what was Woods? In Woods, if you have CH2, Br and Br. Okay, what you do, you make two free radicals, this free radical and this free radical. Then these two free radicals will join together to make this alkene. Same thing we are doing in Kolb's electrolysis, right? Okay, tell me. Right everyone? Okay, that's how it is done. So we can actually write it this way as well, right? We can actually write it this way as well. This will be CH2. CH2, this is the free radical, this is the free radical that is formed, and after that intramolecular is preferred because there is no anti-aromatic compound, so this is formed. Okay, right? Then we have pyrolysis of ester. Now this question is also not like asked to you that much, but still I'll do it. This they can ask you easily, right? This they can ask you easily, right? This they can not that much. This they can ask you just one star. Here you can make multiple stars. It is very important. Here you can make multiple stars. It's very important, right? Pyrolysis is not important for you, right? But still I'll just do this so that you don't have any FOMO that my friend has done it, I have not done it. Why ma'am? Ma'am, why you have not taught us this? Right? So I'll just do it, but it's not important. You can skip this as well, right? It's not that important. So if you see, this is ester, RCOOR. In this case, what we are doing, right, this hydrogen that you have on this position, that is alpha to this, that is beta position to this oxygen, that will be removed. This will be, or you can actually say this one thing, pyrolysis means breakage of this bond. So what will happen, right? Firstly, this particular bond will be shifted here. That's why this bond will be shifted here. So it will give rise to CH3, C double bond O, O negative. And then this hydrogen will be shifted here. This hydrogen will be eliminated and this bond will be shifted here. Right? Okay? Or you can just directly write it like this. This bond will be shifted here. If you see this bond, it will be shifted here. Right, so what you have the formation of CH2 double bond CH, CH3, and there you have O double bond C, CH3, and this is O negative, and hydrogen is being placed here. Got it now? How pyrolysis happened? How pyrolysis happened? This bond will break, this oxygen, and this is partially negative, this is partially positive. This bond will break, this bond will shift here, this will shift here, leading to the formation of CH3, C double bond O, this is O negative, which will further give rise to this thing. Here it will form directly this thing. Okay? And can you see here, this always will give you less substituted product. That means it will give you Hoffman product. You know Hoffman product is what? Whenever you have less alkyl substituted, alkene is formed. When more alkyl substituted is formed, that is called Sedzef, right? When less alkyl substituted is formed, that is called Hoffman. Okay, then guys, we have Wittig reaction. Again, not so important, but you must know this. They have not asked this till now, but they can ask you this, right? Till now means it's not very frequent question, okay? So I'm not marking any star here. This is P, PH, PH, 3 PH are there. This is CRR. When they are reacted with each other, what you have is the formation of this 3 P is there. This is converted to this double bond O is shifted here. This will be converted to double bond O, right? And this will be converted to this CRR will be shifted here. Okay? And that's how you have the formation of alkene and triphenyl phosphane oxide. Okay? Right? This is from halide how it is formed. Right? Then let's talk about physical properties of alkene. If you talk about physical properties of alkene, right? All these are general properties. Here it is cis and trans questions are asked to you. It is your PYQ where they have asked you regarding the properties of cis and trans, right? So that's why it is important for you to know the properties of cis and trans, right? Okay, let's do this. So if you talk about this thing here, dipole moment of cis is always greater than trans, because trans, it is always opposite, huh? Trans is always opposite, so it is always cancelled. This is trans, A and A, it is always cancelled with each other. Cis dipole moment is not cancelled, so cis is greater than trans. Then if you talk about packing efficiency of trans is more as compared to cis. Right? Why? Because if you see, in the case of trans, it is like this. So it can easily be packed like this. Okay? It can easily be packed like this. But in case of cis, it is like this. So it cannot be packed like this, because all of them will be of same size. Right? So it's more of like when you have a chair is in this position. We know that easily we can put another chair on that, on that, on that, on that, on that. But if you have, let's say, if you have same size of some trays, you can't put it across each other, right? Okay. So this is what we want to say, that packing efficiency of trans is more as compared to cis, right? That is why melting point of trans is more as compared to cis, right? This is the order of melting point. And if you talk about boiling point of cis is more as compared to trans, right? Okay, boiling point directly proportional to molecule, inversely proportional to branching, right? That is why cis has, because branching is more in trans, that is why cis has more boiling point as compared to trans. So this is very important, the dipole moment, melting point, boiling point, right? Then you can go through the colors as well. There is no characteristics odor except for ethene, which has pleasant smell, right? Okay. Tell me, before starting addition reactions of alkynes, let's understand this particular part, which is very important for your exam, right? Yes, ma'am, short notes helps us, yes. Like if you write with board, we will write and make short notes easily, so we'll revise it again and again, maybe it will help us. Wait a minute, what you just said. Short notes for that sessions are lined up, don't worry, those sessions will be there. Okay, I'll do organic chemistry in one go, inorganic in one go, that I'll do from short notes only. Even this is, I'm doing, this one is still in detail. Okay? So if you see, there are so many ways that we complete one chapter, right? One way, when I initially do the chapter, like every session is of 3-4 hours. Then I'm doing this, where I'm doing the sessions in just 3 hours, I'm completing the chapter. I'm not missing anything. I'm completing everything, but in a very fast pace, right? Then I'll be doing those sessions in which we'll be again revising, but maybe I'll revise full organic chemistry in just one go, right? There it will be more shorter form. There on one page there will be there, these kind of things will not be there in those sessions. Okay? Yes. No, I am not exhausted, right? Okay, tell me. Shall we now do addition reactions? Yes, tell me everyone. Shall we now do addition reactions? Right? Okay, let's do addition reactions. Right? Yes. So if you talk about addition reactions, remember these things, that cis I am denoting by positive, trans I am denoting by negative. And there are two kind of addition reactions. One is syn. Syn is like from the same side. When, let's say this is a double bond, this is a double bond. When I am adding two things from the same side, that is syn. When I am adding two things, one is from this side, other is from this side, that is called anti. Two types of additions are there, right? One is syn, one is anti. So when I talk about syn addition or I talk about anti addition, how does this work? If I talk about syn addition, that is positive, anti addition I am talking as negative. Now remember one thing, if it is plus and plus, plus, tell me everyone, plus will be plus, minus will be plus, and plus minus plus will always be minus. So in these two cases answer will be positive, these two cases answer will be negative. Let's say I am multiplying -1 and -2, answer will be positive. I am multiplying -1 and +2, answer will be negative. This is what, when you multiply two positives or two negative, answer is positive. When you multiply one positive, one negative, answer is negative. So positive defines for erythio and negative defines from therio. Okay, I'll explain you what is erythio, what is therio. See, erythio is, if I talk about a compound, right, that is, this is Cl is added, here Cl is added. That is on the opposite side, that is therio. This is therio. If Cl is added on the same side, let's say it is added on the same side, that is called as erythio. So when positive is there, it will be erythro compound, negative is there, it will be therio compound. The new addition that you have will be erythro or therio based on this. This is a question they can ask you easily, and if they ask you this question in JEE mains, I will regard it as a tough question because many students don't know about this. Especially when students come for revision, then these things are not taught in revision. These things are taught in full detailed exam. I'll tell you about examples also, I'll explain you. Firstly, let's see which shows syn addition, which shows anti. So whenever you add H2, there will be syn addition. All of that you don't need to remember, just remember whenever you add H2, there will be syn addition. In case of addition of H2, it is syn addition. In case of addition of X2, there is anti-addition. Okay, there is anti-addition, right? Why there is anti-addition? Because of the formation of cyclic compound, that is halonium ion. That is why one halogen is attached here, one halogen will be attached from this side. That is anti-addition. Okay. Now, ma'am, how you are defining that the products are formed, ma'am? How products are formed? Let's see. The example that you were asking from me, let's see how the products are formed. See, if I talk about a reaction, that is, let's say C double bond C. This is CH3. This is H. This is CH3. This is H. Okay. Now, two things we are doing here. We are adding H2, then we are adding X2 here. Okay? Acha, tell me one thing. Addition of H2 is syn addition or anti-addition? Addition of H2 is syn addition or anti-addition? It is syn addition. Addition of X2 is nothing but it is anti-addition. And that is the reason. That is the reason what you will have here because of syn. Now this is cis, isn't it cis? This is cis. Cis is positive, syn is positive. This is negative. Positive will give you positive answer. Positive negative will give you negative answer. Okay. So positive is nothing but this will give you erythro. This will give you therio. Therio. Okay. Now I'll just write it. See. CH3 will write here, CH3 is there, CH3 is there, there is H. Now when I am saying that erythro product is formed, that means the thing that you have added is on the same side. Same side means, why I am adding H2 here? Let's add D2. Let's add D2 because at least I need to see the difference. No, I need to see the difference. That's why I am adding here instead of H2 I am saying D2. They are isotope only, they will also give syn addition. So when D2 is given, so erythro means D and D here. So it will be D here, right? But therio means it will be opposite, so D opposite, and what is added here? Halogen is added, so X here and X here. Okay? Tell me. That is how we use this particular chart. So you can tell that what is the configuration erythro, therio based on anti-syn cis trans. Right? This is an important thing. Tell me guys if that is clear. Chike ji, beta no. They are not enantiomers. They are not at all mirror images. Erythro and therio of same compounds are not mirror images of each other. Okay? Yes. This we have done. Erythro, therio, I have told you it in isomerism as well. Right? Okay? So let's talk about bromine water test here. So you have alkene, you add Br2. This is a test of unsaturation. So bromine water are actually brownish red liquid. So whenever there is any double bond unsaturation present, then this will be converted to this dihalide, and that is why the bromine vapors, it will discharge. the color will discharge, and that will tell you that there is presence of unsaturation or double bond here, right? Next is addition of HX. Now addition of HX can take place via two things. First is Markovnikov addition, then there is anti-Markovnikov addition. So if you talk about Markovnikov addition, in case of Markovnikov addition, remember that Markovnikov addition means negative part will be attached to less number of hydrogens, okay? So Markovnikov addition means this negative part is attached, this is positive, this negative part is attached here and positive part is attached here, and that will be your major product. So that's why this thing is formed as the major product in case of Markovnikov addition. But if you talk about whenever we add peroxide, that is according to Karash law, in this case negative, you use anti-Markovnikov, negative part to more number of hydrogens are added. So negative part, this is positive, this is negative, this is added to more number of hydrogen, that means here. So that means this is the minor, and when there is more number of hydrogen, so don't see here ma'am, some students, you know what they do, they're like ma'am 3 hydrogens here ma'am, more number of hydrogens, are not product side. I am talking about reactant side, more number of hydrogens are here. So Br will be attached here, hydrogen will be attached here, right? Okay. Yes. Extra Y hydrogen we are adding here. This hydrogen will not be there. Okay. So that is your anti-Markovnikov rule. Now remember that anti-Markovnikov rule only applicable for HBr. It is only applicable for HBr. In case of HCl, it is anti-Markovnikov addition peroxide is not applicable of HCl and HI. In case of HCl, it is not applicable because it gives an endothermic reaction. So that's why this reaction will not only take place, because anti-Markovnikov addition is actually a free radical mechanism. That mechanism is not important for you. So I am only discussing important things here. That's why I am not discussing it here, right? But if you want to do it, you can do it in the detailed video. Again and again, I am saying the same thing. I am doing some selective part here in this lecture, okay, right? So here that is not used because it is endothermic. It will not give that reaction. And with HI also it is not applicable because it is endothermic. So in case of HBr, both the steps are exothermic, which results in spontaneous reaction. Hence for HBr you will have difference of this and this. Now if you see in case of HCl, peroxide doesn't matter, you will apply Markovnikov rule. Markovnikov means to the less number you will attach the Cl, okay. H will be attached. HCl, when simple HCl is given to you, again you will do the same thing. To the less number you will attach Cl. But here you will use anti-Markovnikov, here you will use Markovnikov, here you will use Markovnikov, here you will use Markovnikov. Here you will use anti-Markovnikov, CH3CH, this is CH2, this will be Br and this will be H. In this case, you will use Markovnikov, that means negative part to less number of hydrogen. Okay, tell. Clear everyone? Tell. Then you have addition of hypohalous acid. Let's see if you can tell me it in the chat box or not, right? Next is hypohalous acid. So hypohalous acid, again it is HOX, right? OH negative and H positive, again it will be Markovnikov addition. That means negative part is attached to less number of hydrogens. So OH will be attached here and X will be attached here, right? And according to Markovnikov addition, you will have your answer here as well. Then Addition of H2SO4, again in this case you will have H positive and HSO4 negative. So negative part will be attached to less number of hydrogens. If you can see, negative part is attached here, right, and positive part is attached here. Okay, so negative part is attached here, that is OSO3H. Okay, addition of NOCl. Now in this case as well, this is NO positive, this is Cl negative. So negative part is attached to less number of, everywhere I am doing the same thing. This is a Tilden's reaction, right? This is a specific name it has, right? Now, 3 most important reactions we are going to do. Can you tell me what are those? Acid hydration, acid catalyzed hydration, hydroboration oxidation, oxymercuration demercuration. So these 3 are very important reactions that we have, right? So in the case of acid catalyzed, in this case Markovnikov addition with the rearrangement of carbocation will be there, right? For example, you have a compound that is CH3, C, let's say you have C double bond, this is C, CH3, 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 this is CH, this is CH3, this is CH3. ठीक है? So in case of, if I talk about the same compound, you know what I'll do? I'll actually firstly just tell you about this, then I'll do the 3, with only one compound I will do all these 3 things, right? So remember that in case of acid catalyzed hydration, you only do rearrangement of carbocation. In case of hydroboration oxidation, you directly apply anti-Markovnikov rule, and in case of oxymercuration demercuration, you apply Markovnikov without any rearrangement, right? What are the reagents here? Water and acid. Here you have diborane, that is B2H6THF, right? This is used here, right? Then in this case you have mercuric acetate, right? And then hydroboration, oxymercuration demercuration, this is for demercuration. Okay, these are the reagents. Now let's see what is the use of this thing, okay? So let's say I have a compound, let's say this is C double bond C, this is CH3, this is CH3, this is H, this is CH2, or you can just directly write here, this is H, this is CH3, CH3. Okay, or you can just write here, this is CH, this is, let's say, phenyl. Okay, see, so we are saying that 3 things we can do here, 1, 2 and 3. I'll write the answers for all of them. This is acidic, this is first one, this is hydration, acid hydration, this is hydroboration, oxidation, this is oxymercuration demercuration. Okay? So what we are going to do here, see this. In acid hydration, you will always do rearrangement. So rearrangement means you will break the bond, you will make a carbocation. Which carbocation is more stable, this one or this one? This one is more stable as compared to this one, because here the chance of rearrangement is there. Okay? So what you will do here, you will make a carbocation, that is CH, this is phenyl, this is CH3, this is CH positive, This is CH3 and CH3. Hydrogen you have added here. In all these cases, you will make alcohols, right? So in this case, you will now, what you will do? You will do hydride shift, rearrangement. So this will be shifted here, this hydride will be shifted here, it will become CH2. This will become carbocation, this is phenyl, this is CH3, this is CH3, CH3. Okay. Now listen, what you will do next, you will just add OH here. Okay, so this is PH, CH3, this is OH, this is CH2, CH3, this is rearrangement of carbocation that is there in that you have done in class 11 GOC. Okay. Now if you see in hydroboration oxidation, simply apply Markovnikov addition. Here apply here apply anti-Markovnikov. Here apply Markovnikov. Anti-Markovnikov means you should have negative part should be attached to more number of hydrogen, that is here. So it will be CH, this will be CH3, this will be phenyl, and to this CH you will add the OH, and this will be CH, CH3, CH3. Here you will use Markovnikov, that means negative part to less number of hydrogen. So it will be PH, CH3, this is H, this is CH, this is C, CH3, CH3. So less number of hydrogen you will add OH, and here you will add H. Can you see all these products are different here? Can you see that over here, everyone? The products are entirely different here, right? Products are entirely different here. So this is the game of reagents that you must know. This is very, very important. This is very, very important to know where what happens. Okay? Got it, everyone? Tell me. Okay, na? Let's do some more reactions here. Let's do some more reactions. Let's do oxidation, that is Bayer's reagent. Now Bayer's reagent is alkaline KMnO4, which is of pink color, right? Whenever some unsaturation is present, this pink color will be discharged. Why? Because it will be consumed in converting this pi bond to OH and OH. All you have to do is break pi bond, attach OH on both carbons. Okay? So what you need to do, you need to attach OH on both the carbons, just break the pi bond, and that is your Bayer's reagent. That is also a test of unsaturation, just like Br2 water. Right, everyone? Stop chit-chatting, okay? Don't do this nonsense here, right? So let's talk about oxidizing agents now. Guys, see, if I talk about oxidizing agents, there are two things. First is dilute KMnO4, that is Bayer's reagent. That is a weak oxidizing agent. It will form vicinal glycols. Can you see OH on both sides, break the pi bond, attach OH on both sides? This we have just done. Next is if you have hot acidic KMnO4 or K2Cr2O7, which is stronger oxidizing agent. In that case, carboxylic acid or ketones are bond. That means break the double bond, attach double bond O on both the carbons, convert hydrogen to OH if possible. So I will do it here only, right? I will do it here only. If you have what? This is Bayer's reagent. If you have hot KMnO4, what will happen here? Tell me. What I have given, this is a trick that I have given you here. These are the cheat sheets that you have, right? So break the pi bond, attach double bond O here, right? This is H and this is R. Okay, this is attached double bond O here. This pi bond you will break, right? And this is H, this is H, and this is H, right? Now, what the next step? On both carbon, and convert hydrogen to OH if possible. Yes, it is definitely possible. So, this hydrogen is converted to OH. These two hydrogens are converted to OH. This is nothing but H2CO3. H2CO3. This is nothing but it is water. Whenever carbonic acid you have, it is converted to water and carbon dioxide. And you know, in the exam, what in the books, what you will see directly hot cheminophore is giving you this, and then you get confused in that. Why to get confused, right? Directly remember this particular point. This particular page is very, very, very important for you to remember. Okay, tell me. Clear? Clear? Yes, everyone? Next is this we have done. Hot KMNO4 we have done. I have just done it in front of you, right? So why to do it again, right? So complete oxidation part, if you remember, we have done this. In alkane part also I told you 2n plus 2 is 3n plus 1 by 2, right? Then there will be n plus 1. This is 2n minus 2, this is 3n minus 1, this is n minus 1. So I've already told you there, right? Then there is Wacker's process. In Wacker's process, you will have alkene. What you will do, you will add oxygen, PdCl2 or CuCl2 directly. What will happen? This will be converted to same number of carbon, aldehyde or ketone, that is called as Wacker's process. 2 carbon is there and this is converted to 2 carbon aldehyde here, right? Okay, done. This hydrogen will stay as it is. Here you will have the development of double bond, and here this hydrogen will shift here. This will form CH3. Okay, this is what we have done here, right? Now let's see ozonolysis again. Write it, mark it. Very, 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 very important, right? Again, this is a very important reaction and it has been asked so many times, right? I can't even tell you how many times. Thank you. So I can't even tell you how many times they have asked ozonolysis in your exams, right? So many times. It's not a tough question. It's a easy question. Okay, let's do this. It's a easy one. So in case of ozonolysis, 2 cases are possible. Either reductive ozonolysis, O3 you will always add. If you have added zinc and Me twice S, then it is reductive. If you have added H2O2 after this, then it is oxidative. In case of reductive, you just have to break the double bond and attach double bond O. In case of oxidative, you have to convert the hydrogen into OH as well. Let's see how to do this. You have a compound. Let's see. CH3, this is H, this is CH3 and this is CH3. Let's say you have this thing. Now, firstly, we'll make reductive ozonolysis. That means break the pi bond. This will be C double bond O. This will be CH3. This will be CH3, right? Plus, this is C double bond O. This is CH3 and this is H. These are the products of reductive ozonolysis. Okay? These are the products of reductive ozonolysis. If they ask you to convert it into oxidative, then what you will do? If there is any hydrogen that is attached to carbonyl carbon, and I can see only one hydrogen that is attached to carbonyl carbon in both the cases, you just have to convert that particular hydrogen into OH. That's it. And these are the products of oxidative ozonolysis. Okay, these are the products of oxidative ozonolysis. Okay, tell me, Tell me guys, is that clear? Right? That is a product of oxidative ozonolysis. Then we have polymerization reaction, right? So what we do, we form polymers here. Mostly polymers are not in your syllabus, so very rare chances that they will ask you this, right? So we can, and alkynes are like, you can use C. From alkene, from ethene, polyethene is formed. From this propene, polypropene is formed, right? So these are polymers where n number of chains are joined together, right? Our polyethene, PVCs, all are polymers only. Then there is hydroformylation where CHO group is added, right? So whenever to the alkene you add CO plus H2 in presence of cobalt at high temperature and pressure, that is 150-degree temperature and high pressure, in that case CHO will be attached either on this side or on this side. Here nothing is major, this or this which is major, both are in equal proportion, anything can be formed, okay? Then this is again a very important reaction. Mark it important guys, where I am marking now important, you can't miss those reactions. Like here, this reaction, why I have not invested that much time, because this is not that important. This is important. So many times they have asked the question from here, right? So remember that whenever you have Cl2 high temperature or Br2 high temperature or sunlight, N-bromosuccinimide NBS or SO2Cl2, then for example you have this kind of compound, okay, or you have this kind of compound. Now allylic or benzylic positions are substituted. So what are the allylic position? This is the allylic position, this is the benzylic position. Okay, so here this will be converted to CH2 double bond CH, CH2 whatsoever is attached. Let's say we have added SO2Cl2 or Cl2H mu or Cl2H mu. Let's say here you have added Br2H mu or NBS. Here you will form, here benzyl carbon is substituted, so it will become CH2Br. Okay, this thing will be formed here, right? Okay. My skincare routine is teaching you guys. I feel happy. My skincare routine is good comments on my videos, good likes on my videos, and some messages of students saying, ma'am, I did it because of you. That is the skincare routine that I have, right? And what should be your skincare routine? You know, your skincare routine should be studies. That will, you will have glow on your face, right? Okay. So, isomerism. Let's say in isomerism, what we do, we convert one isomer to the other isomer. Like this is position isomer of each other. Here this and this are position isomer because here the position of double bond is changed. This and this are chain isomer of each other. So you can use these AlCl3 or Al2SO4 thrice to convert one isomer to the other isomer, right? Okay. Okay everyone. Now let's get into more detail. Achha, nahi, this one though, this though we have done already. 1, 2 addition 1. Chalo, I'll just show you that. Yes, though we have done it already. Okay. Okay, let's see. So let's see guys, let's complete alkene and then I am going to give you break and then we are going to see alkynes and yes. So isolated, conjugated and cumulative alkenes. So isolated are which are not next to each other, right? For example, okay, let's see from cumulative. What are cumulative or alleles? These are next to each other, double bond, double bond, double bond, double bond, right? Conjugated are when they are alternate, double bond, single bond, double bond, single bond, double bond. Isolated are when the gap is more than more than 2 carbon is the gap. So after this alkene, you have more than 2 carbons after that. That means that is a isolated alkene, right? Now, if you talk about 1,2 addition, 1,4 addition, if you remember, I have already told you that in 1,2 addition, let's say this is the case, right? 1,2 addition will be this pi bond will break. Let's say Br is added here and it is added here. That is 1,2 addition. Do you remember in the starting we discussed from the cyclic process like this? Right, we discussed that how this bond is shifted, this bond is shifted here, this bond is shifted here, and you have the formation of 1,4 addition product. Okay? Okay? Right? In that case, what you have, this is double bond, this is Br, this is Br. This bond is shifted here, this bond is shifted here, this bond is shifted here, and that's how you have the formation of 1,4 addition product. Okay? Then guys, we have Diels-Alder reaction. In Diels-Alder reaction, same thing. You have conjugated alkenes. This is alkene. Now from this alkene, you will make a new compound. How? Let's say this, you can actually do any bond you can shift here. So what I will do here, like I was doing before, I'll do the same thing here. So if you see this here, this will be shifted here, this will be shifted here, this will be shifted here, and hence you have the formation. This is called as Diels-Alder reaction. Okay, when you have conjugated alkene and here you have a alkene. So this bond will be shifted, this bond will be shifted, this bond will be shifted here. That is called as Diels-Alder reaction. Now guys, I'll be giving you these questions for homework. See, explanation, everything is there. Right, these questions are for your homework only, right? Okay, explanation, everything is there. Now next is alkynes. We'll start with alkynes after the break. Okay, okay everyone, right? Right everyone, we'll start with alkynes after the break, right? So I'll be giving you break here for 10 minutes. Right, for 10 minutes I'll be giving you break, and after 10 minutes I'll see you all. Right? Okay, so see you all after the break in 10 minutes, and the time starts now. Hello. Hello, hello. Okay, so yes, guys, we are back. Yes, guys, I can see your chit chats. I was actually reading your chats only in between the break. And I was thinking what you guys are discussing. It's like, yes. Let's see. Let's start again with the class, guys. So, what we have here is hydrocarbons, alkynes. Now we are going to do. Now, in case of alkynes, guys, they are triple bonds. They have two pi bonds. They are sp and linear, right? If you see C triple bond CH, because of only two sigma bonds per carbon, they are linear. They are having sp hybridization. They are cylindrical pi cloud because there is pi cloud above and below. That's why it is a cylindrical, like this cylindrical pi cloud is there, right? Now let's talk about the preparation, and here very important preparation is this first preparation, very important, that is from calcium carbide. Now remember that from calcium CO, that is quicklime, from quicklime when you add carbon you have the formation of calcium carbide, and when you react calcium carbide, very important reaction, when you react calcium carbide with water you have the formation of ethene, and when you react magnesium carbide with water you have the formation of propyne. These two reactions are extremely important. This is ethine and this is propyne. Propyne, you can write it here, propyne. Okay, so from magnesium you have propyne. The difference in the behavior of this and this is due to difference in their structures. Now if you talk about Al, aluminium carbide and beryllium carbide, they do not form any alkyne, right? Okay, they will not form any alkyne. So calcium will give you ethine, magnesium will give you propyne. This should be in your head as it is, copy pasted, right? Very important this is, right? Now next is when you have alkynes, or let's say you have vicinal dihalides. Now from vicinal dihalides, how do you prepare alkynes? Do you remember we have seen that if you have vicinal dihalides, right, then what you can do is from vicinal dihalides, how we used to prepare alkenes? By using zinc dust. Because ma'am, then why ma'am we are not using the zinc dust here? Because guys, zinc dust is for dehalogenation. If you take out halogen from here, you will have the formation of all the hydrogens alkene. So what we want to cause is dehydrohalogenation. Tell me what is the reagent that we used to use for dehydrohalogenation. For dehydrohalogenation, the reagent that we used to use is, tell me everyone, what is the reagent? Name of the reagent is alcoholic KOH, right? So what we will do, X will be eliminated from this side, hydrogen will be eliminated from this side, this bond will shift here. You will have the formation of this alkene, that is resonance stabilized. Now ma'am, how come it is resonance stabilized? These are lone pairs, single bond, double bond. So that is definitely resonance stabilized, right? That is why to take out dehydrohalogenation from resonance stabilized, we need even stronger base. That is NaNH2. So that's why even stronger base is used here, because here NaNH2 has more basic strength. So it will take out halogen and hydrogen from here, forming alkyne here, right? Okay, forming alkyne. Then from geminal means on the same carbon, when you have halogens, same thing you will do here. Firstly, alcoholic KOH, you will take out halogen and hydrogen from here, right? Then again what you will take out? You will take out halogen and hydrogen from here, and hence you will have the formation of alkyne. Okay, tell me, is that clear to all of you or not? Right? Is that clear to all of you or not? Right? Wait a minute. If I take, this should actually not be like this. This should be, this is H we have taken. Wait a minute. Let me just clear this. It should be like this. It should look like this. There should be one X here and one H here. Right? Yes. Now we are taking X from here and H from here, and bond is shifting here, and then you have the formation of triple bond. Right? Okay. So whether it's vicinal dihalides or it's geminal dihalides, you will always use alcoholic QH, then NaNH2 here. Right? Then from tetrahaloalkane, that means 4 halogens are there. Tell me, to cause dehalogenation, what is the reagent? Arey Baba, you just have to remember the reagent. Dehydration is concentrated H2SO4. Dehalogenation is zinc dust. Dehydrohalogenation is alcoholic QH. If just one you want to cause, if you want to cause 2, then it is going to be alcoholic QH and then NaNH2. That's it. Okay. Remember? Then from Kolb's electrolysis, now tell me what we used to do in Kolb's electrolysis. We used to make a free radical here. So we will make a free radical here as well. This is free radical. I can make this here and here. Free radical will be formed. Then those free radical will join together to make your final product. That is Kolb's electrolysis. From Grignard reagent, tell me, what does Grignard reagent do? Tell me, what is the main point of Grignard reagent? Grignard reagent is super good in one thing, taking out the proton source. Now alkyne is, the hydrogen is very acidic in nature. This particular hydrogen connected to this carbon is very acidic in nature. So it will take this hydrogen here, and here MgBr will be connected here. So you will have CH triple bond C, MgBr is connected here and H is connected here to form alkene, right? Now once you have this triple bond here, right, then you, this is R MgBr, then you react this with Ri, what will happen? This is positive, this is negative. This positive, and in this case this is negative, this is positive. So positive will be replaced by each other. This is R, this will be replaced by this R. Now can you see, earlier also you have alkyne but of 2 carbons. Now this is 2 carbon plus R. That means this R can be 2 carbon, 3 carbon, 4 carbon, 5 carbon. Any number of carbon can be this alkyl part. That means you are increasing the number of carbons in this alkyne, and that is why it is called as step up reaction. And this is also a very important reaction. Okay. When what we are doing, firstly we are making, we are replacing acidic hydrogen with MgBr. Then MgBr we are replacing with the R positive from the alkyl halide, and that's how we have step up reaction. Okay guys, stop this stupidities in the chat box, right? If you're not interested, then I'll provide you the PPT. Go and do this yourself, huh? I'm not stupid here for at 11 PM I'm teaching you. Then we will stop this, right? Don't create this nonsense here, right? So from haloform, right? At least if you don't value your time, value those students who are actually here for study, right? Don't create such kind of atmosphere here that nobody would want to study. And those students who are here for study and chit-chatting with others, because ma'am, that person was chit-chatting with me, ma'am, so I was also chit-chatting with them. Are you stupid or what? Exam is in 2 months and anybody can distract you. Anybody. You don't even know their name. They will just come and say hee hee ha and you will be distracted. I mean, that much importance studies has for you. Then you say, ma'am, I really want to crack, ma'am, JEE, ma'am, I really want to do this. If you really want to do this now, then anyone out there will not be able to distract you like this. In the starting, ma'am, yes, super excited for hydrocarbons. Then, hi Nandini, hi ye, hi wo, what is all this? I've been seeing this from like past 1 hour you're doing this thing. Do you value your time or don't you value? You can let anyone take that seat. You don't value it, I think. You don't value in single minute. It's 2 months. It's not 2 years. It's just 2 months. 60 days. Those who are lost in the flow, good for them. But those who are actually, those who don't want to study and are here for just chit-chatting, I don't care about you guys. But those who were like, oh, Diksha Ma'am is teaching hydrocarbons, let's study. And now what you're doing, oh, this person is talking about this, this person is talking about, then beta, why? Why you're fooling yourself? Right? Please don't distract. And I am not going to tell you this again. It's your life. You have to decide what is important. I can't tell you. You are not a 7-year-old kid, right, to tell you every single point, don't do this, don't do that. You can very well decide what is important at what point, right? Okay? Yes. Now, if you see this here from, no. Chalo. Now focus, full focus here, right? Yes. Yes. From haloform, if you talk about haloform in this case, if you see, you have chloroform. Haloform is actually CHX3, that is called as haloform. Now in this case, you just have to add Ag here and you will have the formation of double the number of, that means you will have the formation of ethyne here, right? This is also not a very important reaction, but yes, they can ask you this. Then physical properties of alkynes. So you can see C1 to C4 is gas. It is non-polar in nature because the polarity is cancelling each other, but polarity is still more than alkanes and alkynes because of its hybridization. We know that sp is more electronegative, so polarity is more than alkanes or alkenes, but it is still not a polar molecule. It is a non-polar molecule because it is not very high to consider it as a polar molecule. So it is soluble in organic solvents like acetone, alcohol, chloroform. It is soluble in those solvents, right? Okay. Now the important thing is that, ma'am, acidic character of alkynes, whenever you react this with something like acids, how they react with metals, they take out H positive and convert it into H2 and Na is substituted here forming a salt. So a salt and H2 is released. That means alkynes are acidic in nature. When you react it with any base, whenever a base reacts with an acid, it forms here H2 is released. If it has OH in the base, then water will be released and here salt will be formed, right? That means definitely this hydrogen is acidic in nature, right? Okay, so this reaction is utilized for the preparation of higher alkanes. We have just done it, that how come it is used in preparation of higher alkanes, right? So you have alkynes, you have NH3 here. This salt will be formed. Then this salt, again it reacts with NH3. Wait a minute. No. This will be Rx. Do you remember we have done a step-up reaction before also? There we used to prepare RC triple bond C MgX. Then this MgX was replaced by R dash. Here we are making Na. Then this Na is replacing by R dash. Where this R dash is coming from? This R dash is coming from alkyl halide. In both the cases, that is step-up reaction. So here alkyl halide is used and this will be converted to more high chain of alkyne, that is higher alkyne. Okay. Now, why there is acidic character of alkynes? Firstly, triply bonded carbons are acidic, but not all the hydrogen of atoms of alkynes. The hybridization of carbon atom of triple bond is sp. sp hybridization is 50% s and 50% p character. That's why the electronegativity is very high. Carbon of triple bond has more electronegative so that it can stabilize negative charge better than other carbons, and that is the reason this particular hydrogen that is next to the triple bond, it is quite acidic in nature because of this electronegative nature of this particular carbon, right? Okay, ठीक है जी. Now let's talk about reactions of alkynes. Let's see the reaction of alkynes. Okay everyone, let's see the reactions of alkynes. How alkynes are formed, not formed, how the reactions of alkynes. Acidity of alkynes compared, yes, the hydrogen is more acidic. Okay, hydrogen is more acidic here. Santosh, Nandini, beta, what you are trying to prove by deleting your messages, huh? Why you want me to scold you again and again? Huh? Will anything get into your head? Tell me. Baki yaar, I won't scold you from now. है ना, ऐसे you will see this teacher is so खड़ूस. She is always scolding everyone. What to do yaar? I care for you. I don't want you to waste your time. ठीक है? So, firstly let's see addition of H2. Whenever H2 is added, this alkyne is converted to firstly alkene or then alkane. That is addition of H2. Then let's talk about hydrogenation in presence of Lindlar's catalyst. Do you remember this we have done already. This in presence of Lindlar's catalyst you have the formation of cis alkene. In presence of, this is Birch reduction. In presence of liquid, in presence of sodium and liquid ammonia, you have the formation of trans alkene. We have already done this, right? Then Sabatier-Sanderson reaction also we have done. Triple bond, nickel at high temperature is converted to double bond, and then further high temperature it is converted to single bond. Right? These are all simple reactions. Let's see next one, that is addition of halogen. Let's do this, okay? So this is used as a test for unsaturation. This also we have done in alkene as well. That is bromine water test. In bromine, that is of reddish brown, reddish orange color. So when you add, this is reddish orange color, bromine is reddish orange color. So in the triple bond, when the color of bromine is discharged, that means there is presence of unsaturation here. Break the pi bond, attach Br, and this will be a trans dihalide on the anti position to each other, right? And that is also a test of unsaturation if the bromine liquid vapors are discharged, okay, or decolorized. Then addition of HX, same like Markovnikov rule will be applied, same what we have done in case of alkenes. Negative part will be attached to less number of hydrogens. So here you have less number of hydrogens, here negative part will be attached, here H will be attached, and that will give you alkene. Again, negative part will be attached to less number of hydrogens, that means here and here H will be attached, and that will lead to the formation of geminal dihalides, okay? That will give you the nature of geminal dihalides. Tell me, is that clear, students? Okay, so it's not like some new concept I am doing here. It's not like some new concept I am telling you. I am telling you the same thing. Break the pi bond, attach negative to less number of hydrogen. In presence of peroxide, you will use anti-Markovnikov rule. That means negative part will be attached to more number of hydrogen, that is here, right? Negative part is attached to more number of hydrogen, that is here, and that's how again you will have the formation of geminal dihalides. But in this case the geminal was this one, in this case the geminal is that one. So you don't have to remember anything, just remember that Markovnikov and anti-Markovnikov rules are applied in the same way that we have done before, right? Yes. Okay, how can we say that reactant is that particular reactant? Kya? Means Harshini, I didn't get your question only. Now this is very important reaction. This is also called as Kirchhoff's reaction. Okay, this also has a name, that is Kirchhoff's reaction. So what we do here, negative part, when you add HOX, negative part is attached to less number of hydrogens. So what will happen, break the pi bond, negative part is attached here, X will be attached here. Okay, so this will be double bond OH. Now here you can see there will be resonance, but can you see this is also enol, and we know from tautomerization, then whenever you have tautomerization, you just mark 1, 2, 3, 1, 2, 3. Replace the double bond from 2 and 3 to 1 and 2 position, and H will be transferred to third position. So H is transferred to third position here, right? H is transferred here and double bond is placed here, and that's how you have the formation of alpha haloketone. Okay, you don't have to cram it, right? Okay. No, Pritija, he is fine. Don't worry. Don't worry. He is completely fine. Okay? Yes. Will definitely start for beginners as well. Bala Kumar, don't worry. From next week it will start. Not even next week. From Monday onwards we'll start that. Okay? For 2027 students as well. Right? Okay. Tell me. That is... this is not Kirchhoff's reaction. By mistake, I have written it here. Kirchhoff reaction is different. I'll tell you what is that. Okay. So now let's see hydroboration oxidation. Again, I'll just give you directly here. This also you use anti-Markovnikov rule. Okay. So basically, OH is added to more number of hydrogens. So OH pi bond you will break, OH is added here, H is added here. So this will become this situation. Again this is enol, again 1, 2, 3 you will write, double bond is shifted here, hydrogen is shifted here, and hence you have the formation of aldehyde here. Okay. So in alkynes, tautomerism is very important. You will do the same reactions the same way that you have done in alkene, but the product will always be different. Right? Why? Because here not only alcohol, it is enol is formed. Here also enol was formed, that's why we tautomerized. Here also enol was formed, that's why we tautomerized it. Right? Okay. Then this is the same, this is called as Kirchhoff reaction. Okay. This is Kirchhoff's reaction. Now this is also same category. What we do? We apply Markovnikov addition, that means negative part to, we apply this negative part to more number of hydrogens. So that means OH is attached here, H is attached here. Isn't it enol? Yes, ma'am. Now whenever you have enol, this is 1, this is 2, this is 3. What I told you, that whenever you have to change enol, you have to convert enol, this double bond is shifted here, so this will be C double bond O, right? And here it will be H, this H is as it is, this H is shifted here, so it will become CH2, and that is your aldehyde. Can you see how the answer is becoming different? Thank you, Dance with Music. Thank you. Definitely you can watch this video. but just don't overload yourself, because here it is for not for beginners. I'll just be very frank with you, this video is not for beginners, guys. Okay, you must know something about the chapter to understand, because there is too much information in this particular lecture, too much, it is information overloaded, right? So if you're like 2027 aspirants, you might get scared, so that I don't want to happen, right? Yes. Now let's see addition of HCN. Again, a negative part and this is positive, right? Now remember that in this case we have anti-Markovnikov addition. Okay, negative part is attached to less number of hydrogens. You can actually it will be Markovnikov addition only. Okay, Markovnikov addition only, negative part is attached to less number of hydrogens, then you place it. Like here you have acrylonitrile, which is a monomer of Orlon. Okay, this is extra information that is there. Okay, then addition of acetic acid, again negative part OCOCH3 is attached to less number of hydrogens. Again, Markovnikov rule you will apply, negative attached to less number of hydrogen, you will have your answer, right? Okay. Then now let's see ozonolysis. Now let me be very frank with you, ozonolysis of alkene is important, alkyne is not that important, but you must know how to do, right? Because ozonolysis itself is important, right? Okay. Okay, Abhijit. अच्छा, it's Abhijit's channel. क्या बात है? Dance with music on keyboard. So very creative students we have. I'm already a good guy with this on 12th and I am high for 2026. I'm very good, very good. Acha, see. Oxidation reactions, two kind of reactions will be there. First is with dilute KMnO4, then there is with hot concentrated KMnO4. Do you remember what we discussed in alkene? See, when you discuss alkene and alkyne together, you will see everything is being repeated here, right? So dilute cold KMnO4, there also we used to do the same thing, break the pi bond, attach double bond O here, sorry, break the pi bond, attach OH on both sides. Here also break the pi bond, attach OH on the both sides. For example, this is triple bond, so you will convert it into this OH and OH. Okay, in this case break the double bond, attach double bond O, same thing. Okay, break the double bond, attach double bond O and double bond O. Convert any hydrogen, if for example to this you have any hydrogen present, that will be converted to OH. Same thing that we used to do in oxidative ozonolysis, same thing it is, right? Okay, same thing it is. It's repetition, same thing we are doing here. Okay, yes. Now let's talk about ozonolysis. Ozonolysis, two kind of ozonolysis are there, reductive, oxidative. Now remember that in case of alkene, whenever you have Me2S, that was in reductive ozonolysis. In alkyne, Me2S is in oxidative ozonolysis, right? Usually they don't complicate you that much, they directly give you reductive ozonolysis, or for reductive they will give you zinc, for oxidative they will give you H2O2. Usually this only they do. This much complication they will not do, but still for your safe side I am doing this. See, now remember that you will do the same thing. If there is reductive ozonolysis, you will break the double bond, attach double bond O on both sides. That same thing that I told you in case of alkene. Break the double bond. Now here after breaking double bond also we have extra bond, that's why it will stay. Okay, this is the answer for reductive ozonolysis. This is the answer for reductive ozonolysis. For oxidative ozonolysis, what you have further? Now break this bond as well and attach OH here. Here also break this double bond as well, attach OH here. This bond as well, attach OH. This is the answer for oxidative ozonolysis. Okay? Tell me. Done? Yes. Gets added to hydrogen. More of this. Classes in my Oxford school JEE test, ma'am. Thank you very much. Most welcome, Vignesh. I'm super proud of you. Awesome. Very good. Right? Ma'am, difference between Markovnikov, Bala. Beta. If you're in class 11th, please watch the detailed one shot, because this is for those students who are revising hydrocarbons for 2026. Okay? Because I know you are fresher, that's why you will have so many things in your head that I won't be able to answer in this class. Why? Because I am focusing more on those students who are in the panic zone. Ma'am, I have exam in 2 months, right? Okay? So, oxidation reactions are, for example, you add selenium oxide, this is converted to CHO and CHO, right? Then substitution reactions. How substitution reaction works? Now, because of the acidic hydrogen with any base, this hydrogen is substituted by sodium. There are other substitution reaction as well. If you see this with CuCl3, this hydrogen is substituted by copper and that give you reddish brown PPT. If you have AgNO3, and this is a type of tolerance test. Okay? This is a tolerance test even if it is not giving you silver mirror. Right? So here this hydrogen is replaced by silver and it gives you white precipitates. Okay? Right? Copper looks like what in color? Copper looks like reddish brownish in color, so that PPT. Silver looks like white in color, not white, actually it's a silver, but still will consider whitish, we can say. So it is white PPT, right? Then polymerization reaction, just like alkenes, you have polymerization reaction of alkynes. Not important for you, so I'm going to leave it, right? Cyclic polymerization, extremely important reaction. Very important. See, these are the things that are missing in your revisions, right? When you do it yourself. When you do it yourself, you don't know. You are like, okay, you know how you do revision. Tell me if this is correct or not. I know that this is not important, but you will invest time here. Now, it's not like all the students will not know that this is important or not. Only those students will know who have revised previous year questions like so many times. They know that, okay, this question, though it is never asked, right? There is no point of asking this question, right? So these are the things that are important. Now, you think that, ma'am, why you are taking this session in just 3 hours, ma'am, this big chapter? Ma'am, why so much fast pace, ma'am? Reason, because I want to tell you that these are the things to revise, right? That is how you're going to save your time, okay? Yes. So, wait a minute, Harshni, let me see. Ma'am, if any element reaction with some element gives some product, how to write product? Any elements on reaction with some element. Beta, I am not able to understand what you are asking. If any elements on reaction with some element give some product, how to write product? Beta, acha, you are saying how to tell whether this is a product. Beta, this is a matter of practice. More you practice, more you will get to know about what is the product that will be formed. Now see this question, that 3 moles of acetylene, 3 moles of acetylene, what will happen is cyclic polymerization will take place. This bond will shift here. This pi bond will shift here. You know, instead we can write it very simply like this. we can actually write it like this. This bond can shift here, will shift here, and this bond will shift here, making new bonds, single bonds here, and these triple bonds are converted to double bonds, and that's how you have the formation of benzene. And very famous thing that is written in your exams, that is RHT. Sometimes it is just written RHT, RHI, that is red hot iron, red hot quartz, right? Or you can say red hot iron tube, red hot tube basically. The tube can be of iron, copper, quartz, right? So usually it is written red hot tube, RHT. Whenever you have acetylene, you have the formation of benzene, right? This is a very, very important reaction. Mark it as many important that you can mark here. Please, please, please. Okay, beta, this is very important reaction. Very important. Do you remember all the things that are marking important? I am telling you, I am guaranteeing that question will be asked from there only. What I am telling you, right? Not beyond that, questions will not be asked. If I am saying it is guarantee, I am not an astrologer. If still I can say, that means it is a pattern, some kind of pattern that I am telling you. Okay, but these questions, so I am giving you for homework only. Okay, answers everything I have written here. Okay. Acha, one more thing I want to tell you here, that wait a minute. One more thing I want to tell you here, that just like from acetylene, you have the formation of benzene. Okay? Then if you have this propylene, okay? From propylene, what you have? Tell me. From propylene, you have the formation of this mesitylene. Okay? This is also very important. Okay? This is also very important. Right? Yes. Ma'am, please reply, is there full one shot of classification? Yes, yes, as if there is periodic classification, full one shot, I don't know, one shot, maybe last year one shot will be there, because this year I have taken detailed lectures, so you can see 2-3 parts. In 2-3 parts, each part will be of 2 hours, so you can see 6 hours will be the full chapter, so you can watch it like a one shot only, right? Okay, yes. Acha, now these are the questions that I am giving you for homework, right? Let's see, let's talk about benzene, right everyone? Let's talk about benzene, last part of today, right? Okay students, and let me see how many likes you have given, right? At 11 AM we are teaching you, so we deserve likes, isn't it? Acha, tell me, will you do homework? I am giving you full-fledged questions, previous year questions plus answers I am giving you. Tell me, will you do that? Can I trust you this much? Will you do that and let me know in the comment section by tomorrow that, ma'am, I have done my homework. I have given you, see, even the solutions are given to you. Okay, I am not going to spoon feed now. Like, let's see, this is a question. Which will be the major product of the following sequence? N-butyl, this is the question. Then this is given, this is given. We know the use of these two things, right? You just have to add it here and you will get your answer. Right? Okay? Chalo. Yes, ma'am, tomorrow same time, ma'am. Tomorrow, though, I'll tell you what is there. Okay? Yes. So, firstly, let's see what is benzene. Firstly, benzene, if we talk about its resonance hybrid, it looks like this. But its Kekulé structures, that means its resonating structures looks like this. Okay? So, that is cyclohexene actually, not hexane. It is cyclohexene. Right? Okay? So, preparation of benzene, firstly see, first is cyclic polymerization of ethylene. So this is ethylene or acetylene. Its cyclic polymerization is going to give you benzene that we have just discussed. Red hot tube, it can be iron, copper or quartz tube, or cobalt CO8 plus Br2 can also, this you will very rarely see, this you will see more, right? Okay. Then decarboxylation of aromatic acids. So, do you remember we used to do RCOONA gives you RH. So, this is R, this is CONA, this is going to give you RH. That means benzene H. That means this phenyl plus H, that is nothing but benzene. So, it is going to give you benzene as the answer. That is soda lime decarboxylation. Then there is reduction of phenol, again very famous reaction. Phenol with zinc dust. This is zinc dust. It is directly going to give you benzene. Okay, it is directly going to give you benzene. Next we have from chlorobenzenes, how it is done from other methods. Let's talk about this. So if you talk about this is RX, this is like you are adding hydrogen here. So directly this Cl will be converted to hydrogen directly, or you can firstly convert it to RMgX. It is like RMgX. Tell me, what is RMgX? Is a very attractive to which thing? It is very attractive to protons. This is a crazy for protons. It sees a proton source, it accepts it. So when you give it proton source, it will accept the proton source and will be get converted to RH. That is nothing but this R is this phenyl plus hydrogen, that is benzene. Okay. Can you see same reactions are repeated here, right? So when you say organic chemistry is tough, I believe that practice is less. You are actually memorizing these reactions. You don't have to memorize. You have to relate the reactions with each other. Yes, there are things that you need to memorize, but these things you don't need to memorize. This you don't need to memorize. This is again, this is a new one. This thing you don't need to memorize. This is decarboxylation only. This is again repeated question, right? Acha. Then tell me about sulfonic acid. From sulfonic acid, you add H2 and HCl. It is directly converted to benzene. Not so important question. From disonium salt, this one is important. Okay. Firstly, disonium. Firstly, we have disonium chloride that we form by adding NaNO2HCl. This is disonium salt that is formed. Now, disonium salt is only stable between 0 to 5 degrees Celsius, right? So, that is the reason whenever you will vomit, it can show so many different types of reactions that you will discuss in other chapters. But as of now, when you react this with H3PO2 or ethanol, this will directly give you benzene. Okay? This will directly give you benzene. This is called as till here it is called as diazotization. Now let's talk about physical properties of benzene, right? First is why it is called aromatic hydrocarbons are non-polar because they are always cancelling each other, usually colorless and have characteristics aroma. Naphthalene balls which are used in toilets and for this is we know that we use to preserve our clothes. Aromatic hydrocarbons are immiscible with water. They are not mixed with water but are readily miscible in organic solvents. Miscible in organic solvents. They burn with sooty flame, right? Then let's talk about the chemical properties of benzene. Let's see last part of today. It is easy to complete in any reactions, ma'am. Thank you, ma'am. Thank you, Vignesh. Thank you. है ना? See, every single part that you will see for hydrocarbons, none of them will have like it will obviously have the same content, but the way I am presenting the content will always be different. Now if you see on this channel only, you will see hydrocarbon which is completed in detail. Like in detail means 2-3 lectures I have taken for that. You can watch that. You want to complete it in 3 hours, you can watch this. You want to complete it in 6 hours, you can watch the Vignesh that he is studying. That was a 6-hour lecture, I think 6 or 7 hours. You can watch that, right? So it's totally your choice. Everything we are providing now, it's your choice how much time you have, right? So based on your time, we have decided that okay, this much you should do, right? For 3 hours, the things that I am covering, you do this and you will be thankful to me, right? So see this, chemical properties of benzene. We have arenes are characterized, I don't know what is happening to my language, guys. So arenes are characterized by electrophilic substitution reaction. Electrophilic substitution means electrophile. Electrophile is electron loving, that itself is positive. It will substitute the hydrogen on the benzene rings, right? Under special condition, they can also undergo addition and oxidation reactions. So first we will talk about electrophilic substitution reactions, okay? So always there will be an electrophile, that is E positive, that will attack on any of the position and replace hydrogen and substitute it with the electrophile, okay? So in case of halogenation reaction, you will use Cl2 and dark FeCl2. This FeCl2 is a Lewis acid. That's why it is electron deficient. That is the reason from the ClCl, it is going to take away Cl. It will become FeCl4 negative. And this will be the electrophile that is generated. This electrophile will replace hydrogen and will become halobenzene will be formed here, right? Then in nitration, you have HNO3 and H2SO4. That is a very good nitrating mixture. This being a strong acid, this still being an acid will behave like a base. So it will behave like a base because it is in front of a strong acid. What it will do, it is going to take H positive from here. This will become, wait a minute, base is going to accept H positive. This will become, and this is going to lose H positive. This will become HSO4 negative. This will become NO2. This is OH already, and this is going to accept H positive here like this. And here you will have, and here you will have this positive here. Now this is going to take away water from here, and you will have the formation of NO2 positive, which is your electrophile. This electrophile is going to replace hydrogen here, right? That is called as nitration, right? Okay. Then this is your question of 2021, benzene or nitrating in presence of this mixture where both are acting as acid, both are acting as bases. So this we know that act as a base and this acts as an acid. So this was a very simple question that they have asked in JEE 2021. So quite simple. Huh? Then in sulfonation, what we do? We have sulfonic acid or oleum, right? Let's talk about this. Oleum is this thing, oleum is this thing, you have this, or you have fuming sulfuric acid, right? Now here, what we are going to have is an electrophile. Electrophile is neutral here. Neutral electrophile you will have here. You know what will happen in reality? This will attack here. Then internal transfer of hydrogen will take place, and that's how you will have the formation of SO3H. Electrophile is SO3 only, but after internal transfer you will have the addition of H there, right? That you must know. Then Friedel-Crafts reactions. Two kind of reactions are there. One is alkylation, then there is acylation. In case of alkylation and acylation, what we do? Let's see this. And we always use catalysts like Lewis acids, like AlCl3, FeCl3, SbCl3, or protonating agents like these, right, that are going to give protons to make acyl and alkyl group. Okay, so what exactly we do? We use these Lewis acids or protonating agents so that here we form R positive, and here if rearrangement is possible, that will take place. Okay, whenever beta there is a formation of carbocation, rearrangement will always take place if it is possible in that case, right? And that's how you have the formation of R positive alkyl carbocation. In case of acylation, this is the electrophile that you have. This is acylinium ion is the electrophile, that is RCO positive, that is going to attack on this benzene and is going to give you COR here, right? Limitation of Friedel-Crafts acylation reactions are that aryl and vinylic. Now, Friedel-Crafts reactions do not take place when it is aryl or vinylic halides, because carbocation is not stable here. As do not form carbocation easily. This carbocation is not stable. This carbocation is not stable. These are not stable carbocations. So these reactions will not take place. Next is, in case of anilines. See, this is an acid, this is a base. Instead of making an electrophile, this acid and base will react with each other, and what it will do, it will form a salt like this. Okay? That's why they are not applicable in case of aniline. Okay, ji? Then guys, we have 2-3 addition reactions. Let's talk about that. Electrophilic substitution. I think chemistry is quite logical. It's just that chemistry is like, it's not, I can't say it is illogical. Yeah? Science itself is logical. If you say that science is illogical, then you have not understood science at all. Yes, there are exceptions, because maybe we are not smart enough to understand that what is a proper theory where all the things can be combined. That's why there are exceptions, right? So, addition reactions, whenever you have benzene, you add H2 in presence of nickel at 150 degrees Celsius, all the double bonds will break and you have the formation of cyclohexane. Then guys, you have benzene, you add Cl2. Now this is very important. Benzene, when you add Cl2 in presence of H mu, then you have the formation of gamazene. That means you will break the pi bonds and each carbon will have 1,1 chlorine. That is gamazene. But when you add Cl2 in anhydrous AlCl3, pi bonds will not break, but you will have Cl in all the carbons. That is the difference when you have Cl2 in presence of AlCl3 and Cl2 in presence of H mu. Then Birch reduction. Birch reduction is, if you remember, we have done it in alkyne. Alkyne to alkene, you have the formation of trans-alkene. But in case of benzene, you cause Birch reduction, you will have opposite double bonds here. Only 2 double bonds will be left that are opposite to each other. Now remember one thing, whenever an electron donating group is attached to the benzene, someone is donating you something, you will stay next to them. So it is donating, that's why this double bond will stay intact, and opposite to this you will have a double bond. Whenever you have electron withdrawing, then if someone is taking away money from you, you would not want to stay with them. So this double bond will not be there. Instead, this and this double bond will stay intact. Okay. So these two. Ma'am, why not this and this? Because this is next to this. Ma'am, why not this and this? Because this is again next to this. That's why they are, this double bond is important. Right? Okay. Then oxidation reactions. Now remember that always, whatever is the alkyl chain, this alkyl chain can be 1000 carbons also. Whenever you use KMNO4 here, this alkyl chain will directly be converted to COH. That is called as side chain oxidation. Again, this is a very important reaction. Now remember, the carbon attached to benzene must have alpha hydrogen. This carbon that we are saying, this must have alpha hydrogen, and alkyl can, this R can be alkyl, alkenyl or alkenyl or acyl. That means it cannot be tertiary in nature. Okay. Then last is, let's do just 3-4 more things. After that, so just 2 more slides we have. Combustion reaction, guys. Combustion reaction not so important, right? When it is heated with oxygen, produce carbon dioxide and water. That's it. You don't have to get into to that much detail of this thing, right? Then nucleophilic aromatic. Now this thing you actually have in haloalkenes and halorines. So addition reaction and elimination, 2 kinds of reactions we show. If you remember in haloalkenes, in alcohol, phenols and ethers, you will do this. In addition, do you remember you had this thing? I'll just give you one example so that you can remember that we will do this somewhere. If you have this phenol, not phenol, let's say you have chloro. Okay? If you have NO2 here, NO2 here, NO2 here, this I have already done in alcohol, phenols and ether. In detail, I have taken these things. You can go and watch that, right? So addition elimination in this case occurs when strong electron withdrawing groups is attached to benzene. When you convert this to OH, this is NO2. When this Cl is converted to OH, this is called as addition elimination. Okay? Here, firstly, we will add OH, then Cl is eliminated. It occurs like that. Okay? And when you have, same thing we have, chloro, but here we have very high temperature, high pressure. This is Dawes process. Then this is converted to OH. Here what will happen? Firstly, Cl will leave. You will have the formation of benzene. See, formation of benzene is there. What is benzene? I can also write it here. Benzene will be there. You will see the formation of benzene. Then this will be further converted to phenol. Okay? So that is your elimination addition reaction. So these things you will study further. Okay? Yes. If you want to see this in detail, you can watch my alcohol, phenols, ether detailed lecture I have taken here. In part 2 it will be there. And these are, guys, some questions with answers. I have given you some questions for your practice. Right? Now, I have done my part. Let me see if you do your part as well. If you solve the questions or not. The PPT will be provided to you by tomorrow, right? Because the team will not be available at this point. So tomorrow the PPT will be uploaded, and I genuinely want to see how many of you genuinely are interested, because guys, practice is what is going to make you. Even in our Sigma batch, it's not like we are spoon feeding. Yes, there are topic wise, like if I teach a topic, I'll teach one question related to that, 1 or 2 questions. But I'll also give homework. Students also do their homework. Students also have test series, right? Not on daily basis they have test series, right? So if you think that just by doing theory part you will be able to make it, no. You have to practice questions yourself as well. Okay? So all I'm expecting from you is solve the questions. If you're not doing that, you are really doing a big mistake. I am giving you even the solutions of these questions. Go and solve that. That is your homework, right? Okay? Tomorrow you don't have my class, so tomorrow is your duty to do this, right? Okay? Yes, everybody? Chalo. Ma'am, what if this is taken in place of dim sunlight? What? RX, what is reaction takes place in dim sunlight but still sunlight? If sunlight is there, dim or this, the reaction will happen like that. Okay? Okay? Chal. Okay then guys, now I'll see you all in the next class. Bye-bye, take care, and I'm waiting for your comments in the comment section. Bye-bye, take care, bye-bye, see you all, bye-bye.